If you recall, we just talked last time about the air pollution system and things like that. If you look at this particularly, I borrowed this slide from a friend who or she is from Norway, and I like this slide, so I thought I'll show you and share you this slide with. See, sometimes you say why air pollution, okay, and in fact, air pollution is a bigger stressor than many other things from where you can be exposed to, or you can, the environmental factors which can cause the ill effects. So what you see here is a very interesting thing, is that when it comes to the doses or the quantity, okay, because what could be contaminated? Air could be contaminated, the food could be contaminated, the water could be contaminated. Look at the amount of the things which you take, okay, it's almost like per day kind of stuff which you see here. 13.5 kg of indoor air, or nearly about one. You see the interesting things, okay. Very quickly tell me that, do you have any idea as to how much air we breathe in every day? Well, it depends on certain factors, it depends on the body weight, it depends on age and things like that, but you see, you'll be surprised that we almost take about 20 meter cube of air per day, approximately, but it depends on many things. You know, the children will take less, but you see, the air is so important because the major amount or the major environmental stressor could be air. So just to give you a feel, I'll pass on these slides to you, don't worry, but you should, you know, you should be able to highlight that why the air is important. You see, the quantity of air, the little pollution in air, the dose becomes more because volume is high. So even if the concentrations are in micrograms per meter cube or even in nanograms per meter cube, when you talk in terms of the doses, and what really affects is the dose sometimes, not the concentration. So when you multiply by this meter cube, with this quantity, the dose becomes quite significant. So air pollution is an important thing, and sometimes this may not be quite true, that you see the indoor air in India. Indoor air is important, especially in the villages, in the kitchen areas, but our houses are very airy. We have lots of windows. So the difference on an average cycle out 24, not so much about the indoor air and outdoor air, because but then if you move to the Europe or the colder countries, you see many people spend a lot of time indoors, because indoors it could be all, you know, the outside playing is very little. So indoor air is also important, the external air or outdoor is also important, and of course, so you see how important is the air is. Okay, this part we had discussed briefly, okay, but I want to slightly, you know, highlight one point which we had somehow not, you know, focused on. Okay, what you see here is when you look at the troposphere and the temperature is changing, and we said why the temperature is changing. Look at that picture on top, okay, and that little white band that you see around the Earth. This band is narrowing as you go into the poles, okay, and you see when we look at the temperature profile in terms of the gradient, it is the same, but the height of troposphere will be different at poles, and it will be different on the equator or tropics and things like that. That is clearly seen here, as you see here. Here the depth, this is what is being shown as the troposphere, this is more here and this is less here. The reason is, this range is due to the temperature difference between the tropics and the poles. Poles, the temperature is much lower, nearly 0 degrees or -5 or -10, and equator the temperature is high, so heating is more, and this kind of gradient, okay, you see largely because of the influence of the Earth, because Earth gets heated up, right? When the Earth gets heated up, so the surrounding air gets heated up, the upper air is still cold. Okay, so you see the influence at the equator because of the difference in temperature. This is more, and the tropospheric part, okay, of the atmosphere, we consider it almost going up to about 18 to 20 kilometers at the equator, and while it could be about 9 to 10 kilometers at the poles. So that a little subtle thing which we should know. Okay, so that's what I wanted to put the slide and to make the picture very clear, and the reason is down there. Okay, we also have seen this thing and we have discussed as to why there is a temperature profile. Okay, this of course was made very clear to you that why temperature decreases as you go up, okay, and then why the temperature increases in the stratosphere, as most of you had pointed out. It's the ozone which absorbs the UV radiation, as a result the temperature increases. And as you still go further up from stratosphere, sometimes we also call this as the ozonosphere. Okay, as we go up, the ozone is not there, and once ozone is not there, the temperature will start. That's what we call mesosphere, and it goes almost up to 90 to 100 kilometers. Okay, and the temperature would start decreasing once again, and then something like after that, which almost go up to 500 kilometers. So the temperature starts increasing because largely it is the oxygen which is present, and oxygen do absorbs a lot of UV radiation in the lower range. So that's again the temperature goes up. So that's what was the reason that we discussed. If you recall very quickly, this is the definition that I gave you last time, and I did write it on the board because the computer wasn't working. And you will also recall that in this definition, as you see the definition, we had identified some keywords. Okay, and the keyword was such a concentration, and then all the discussions that we had in last class were focused on this. And in fact, this word concentration, such a concentration, is the crux of air pollution problem. Okay, so this is important, that what is that concentration which is not a problematic thing, which we could be very happy that even if some pollution level is certain this thing, we might still be saying, well, all right, this is not a pollution. In fact, we don't even call it pollution. Simply saying that SO2 is there in the atmosphere does not constitute a problem of air pollution unless it exceeds a certain concentration. But we are trying to say that what that concentration is, since that concentration decides everything. It decides what kind of car you should have, that will decide what kind of power plant you should have, that may decide what kind of LPG you should burn at the home. So everything is decided by that number. Okay, and that is what is our goal, objective. And we also said that this can also be a standard. And when I use the word standard, the moment you see the word standard in terms of the air quality, it has legal connotations. Okay, it means it is something legally binding, that is, in fact, that is how the people can demand the cleaner air. Look, they can go and shout at the government, they can go and shout at the regulatory agencies, look, this is that standard, and you are not able to provide that kind of level, good quality of the level of air, so there is a problem. Okay, so in this lecture we'll try to somehow, at least in some brief sense, that we'll try to say how to arrive at such an important number. Okay, very important. I mean, apart from apart from science and engineering, we all do. We should also understand the things. Its implications, what it means. Number is fine. Equations are fine, very good. But then you are not just dealing with equations, or you are just simply not mathematicians who will sit and write the equation or solve the equations. Okay, you're an engineer, you're out there, and then you have to solve many problems. You have to give the solutions. Okay, all right. If you recall, see, clean atmosphere, some external addition, but that addition has to be to the level that it causes the effect which is not acceptable, and that is what we call as the air pollution. So, and the philosophy that I repeat from the last class, the philosophy is not to make zero pollution. The philosophy is not to make the emissions zero, so that we don't want to make the emission zero. We don't want to close the power plant. What we are saying is that we are not talking about zero pollution, we are not talking about absolutely pristine time pollution and things like that. So we have to find out, we have to reduce the emission only to the extent that there is no noticeable adverse effect of the pollution is seen. To determine the extent of the reduction, okay, so this is a philosophy, and what is that? Now the idea of the engineers is to understand and establish, okay, understand and establish the linkage between the source and the receptor, and the linkage is provided by the atmosphere or the meteorology, okay, and that should be able to give you that, well, how much control is to be done to make the receptor safeguard, okay. So that is what we need to see. So this will give rise to something what you are calling such a concentration or air quality standards to protect the receptor, okay. So that's what is the thing which we had discussed last time. I'm just trying to think that if there is anything else we need to specify here, okay. Well, all right, let's go to the next slide. We can, with the slides we can go a little faster, and we also discuss as to what are the little difficulties which we see, or what are the, not difficulties, but the challenges that we face when we talk about the air pollution control. Air pollution problem, or any problem for that matter, is always an inverse problem. You start with the problem at the receptor and try to see where the changes need to be made, okay. So it's always an inverse problem. We don't start from the source, but we start from the facts and then look to do this, what the changes in the source. We also talked about the source remediation, medium remediation, and the receptor remediation. And I gave you a little example how the receptor can also be remediated. The way the way the Taj Mahal is being protected, you know, with all the plantation and the trees and the development of the forest in that area, so that you don't, the pollutant somehow escapes, okay, and doesn't quite go to this thing. Okay, now we are coming to an important question. Well, having said that, we also need to say why control the pollution, that we have specified in some sense, okay. Then question also may come, which pollutant? So we should all not only know that, well, we have to control this, but which of the pollutants? There may be so many pollutants, okay. Sometimes we need to fix the priority as to what we can do or what we cannot do. How much? That also will, the answer will come from our inverse problem. Do we have the money to do that, okay? Is the society ready to spend the money, okay? What are the short terms and long term gains? You know, you sit down with the economist, okay, economists and engineers will always fight, or scientists will, and say there is a fact. The economist will say, where is the cost benefit analysis? What is that you are gaining out of this, and what you are spending for this one, okay? So they will always insist on cost benefit analysis. And let me tell you, with my experience, when it comes to between the scientist and the economist, the scientists, with their, because of their knowledge and the argument, they can always win, okay. Can it be sustained? You can talk about the hi-fi technologies, but can it be sustained, you know? And then you have to, once you have a system in place, okay, there must be someone overseeing the system, whether the system is working or not, okay. That's very important. If you don't oversee the system, well, you might put in the place lots of things through the documentation and reports and things like that. Well, they are lying just like that. So this is how, again, we handle the air pollution. But somehow in this course we'll somehow touch upon these points, but let's go on to something more important thing. This figure is very important, okay. This is more like, right now is more hypothetical kind of, okay. Why it is more important thing? You see here is the dose of pollutant on one side. You see here the dose of pollutant is on one side, okay, and what it can cause in terms of the effect on the body. Whenever the body is stressed because of anything, including your stress due to you have to do well in the exams and there's a pressure for the examination, body responds. There's a lot of biochemical reactions that goes on in the body, and the body first try to stabilize itself. So you see here there is a dose of the pollutant, and you see there is some response in the body, and you keep on increasing this thing, body will try to adjust as far as can. It can eventually, if you increase so much of the pollution, okay, it will lead to the death also. So people have observed that there's some this kind of the relationship with the response to the dose. But this also has been seen that up to certain levels, okay, the response is not seen. Okay. There could be many reasons. Either the body can resist this kind of pollution level as you see here, the dose, or what else? Your instruments for the measurement of the blood response may not be so sensitive. It could be possible. I mean, the body is responding, but you are not able to measure it, you are not able to see it. But with science getting better and better, many people have kind of come up that, well, it is not quite as simple as that, okay? Because this you are not observing. Many people say, well, that the effects are there. And things with time, as your analytical capability, as your instrumentation quality improves, the people are able to say this thing. So, so such kind of thing which shows no effect, if you look at this dose level, these levels are called as threshold limiting value, or TLV. Okay, I don't know if that I write here. That is called TLV. In fact, the terminology TLV, that first came from the people who were working in the occupational health. Because the first ever effects of air pollution was seen in the occupational areas. Okay, where the people were exposed to the higher concentration, and they would have the illness which other people in the society will not have. They will die early, they will suffer from the cancer more frequently than the normal population and things like that. So people from the toxicological group and more of the occupational health and safety, they kind of did the study, and then they come up with these numbers called TLV, okay, threshold limited or limiting value actually. And then they also used to write little thing here, and which is very important in fact. Can you see in the back this is written 8-H? Because when they were, why they call it 8H is mostly the shifts, okay, in the factory would be about 8-hour shift. So they say this is the 8-hour exposure, okay. So time thing is such an important thing. So then apart from, once the people started doing this thing in the occupational area, the people in the toxicology or the research, people started doing lots of research, and we call it, some of this research we call as epidemiology. So there are people experts on epidemiological studies, and they started doing the studies on the rats, on the animals, and also people study on the people. Some people came forward and they said, we are ready to be exposed to the higher concentration, please examine us, and things like that. So it is like this science has been going on for the last 100 years, okay. And that is important, that, you know, like for the mankind, some people come forward, some of the animal studies are there, and then what the people have done is they can go and study, like Delhi is a polluted area, or some area, let's say, could be very clean. Okay, I was showing a picture to the class in the morning, Delhi versus Himachal Pradesh. So some of the studies can be done, and the people can be largely, in a statistical sense, then what kind of responses they have. So a lot of science that has gone into that one, but I'm just showing you that you get the feel, but don't forget at the back of mind where we are trying to go from here to that concentration, because that is a crux of the whole problem. Okay, so having said that, if I ask you a question that, well, what should be, having given you this thing, we are still on hypothetical kind of a pollutant which we are, having given you this thing, what, can you say something as to what should be the concentration? Suppose this curve is this, for example, this is for sulfur dioxide, okay, and then we have to establish that concentration so that people could be exposed and still be living very happily, okay. So what would that concentration be? TLV, okay, alright, TLV, so that's what I've written here. Can that be such a concentration? Obviously that looks a reasonable answer to the problem, well, we have the TLV and things like that. Having said that, do you, when you design something, okay, many of you are engineers, civil engineers, you have, okay, this is the capacity, bearing capacity of the soil, okay. Do we take that as the design capacity, or we do something else? Factor of safety, okay, that's extremely important, okay. So we know, well, there is a problem just about to happen here, okay. So we can't start from here. Suppose this is the way as engineers we see the capacity or the strength of the material. So this is the strength of your body, Okay, so you put the factor of safety because you don't know how the instruments are being treated here. Was the person or the animal was tested, what could be resistant to that kind of pollution and things like that. So we always provide a factor of safety. Factor of safety is, in fact, it is not a factor of safety, but it is factor of uncertainty or factor of ignorance. Because our knowledge is poor, so we sometimes take the factor of safety. Given a better name, because we want to call ourselves as a better, don't call us ignorant people, but say, oh, let's take a safety. But essentially, it is a factor, I wouldn't say the factor of ignorance, but factor to account for the ignorance. Let's put it this way. So, when your knowledge is good, very good, your knowledge is very good, your instruments are very good, the factor of safety can be smaller. Or when your instruments are very crude and well, we don't know, so let's be safe, and so then factor of safety will be large. So that's something similar to that we do, and then normally it is TLV which is available, we divide by some factor of safety, and it is not uncommon to take the factor of safety because we are dealing with the human health is sometimes taken in the range of 10 to 100. Okay? So this is how we are trying to define as to how we can arrive at as those concentration. Any question? Okay, let's move further then. Now the question comes, apart from this is fine, 10 and 100, but again, since the standards are country specific, there should be a national consensus. What I mean to say national consensus means between the regulatory agency, between the scientific community, between the industry, because see, we can't put this number here, and then if you put this number here, well, somebody might come and argue, let's take the factor of safety as 1000, and then you will probably have to close down all the industry in the country. Okay, so there has to be, it's not a perfect solution, but something which you agree upon through the various meetings, discussions, arguments, fights, because the implication of this number, as I have been repeating all the time, is very, very important. It means a lot. It means a lot to the country. It means a lot to the people. So there has to be a national consensus on this. Apart from that, we should also look at what is the background concentration of the pollutant that we are considering. See, when we are not doing any of the human activities and background pollution level itself is very high, okay, we cannot bring down the concentration to the lower than what is the background pollution. I've gone to, let's say, I go to very clean area and measure something. Of course, your health might say, well, this might be a little trouble here, but then the background level itself is very, very high, because this also leads to a planning for the pollution control. So, well, we can say, well, the background level is high, but we'll look at what are the sources of the background level. The background level could be because of some other thing happening somewhere, maybe in some other country for that matter. Okay. So we have to see the background level, we have to see the financial resources, we have that thing, and then that's how we come up with the ambient air quality standards for something which we are not very sure. We call that as goals and guidelines, because something you want to give that standard, you are pretty firm about it, that this is what the number is. Sometimes otherwise, we give the goals and guidelines that we have discussed in the last class. So you have some idea as to how this number can be such a concentration, which I am trying to overemphasize again and again is so important. This thing. So we also will see some more interesting things about the making the standard, and this is a picture borrowed from no, this is not the correct picture. Okay, so the science, okay, that develops the dose response, okay, is called the criteria. Is the basis, is the knowledge. Okay, so always remember the criteria is not the standard. Criteria is the knowledge. Criteria is the basis on which standards are built. Okay, sometimes there is a lot of confusion between criteria and standards. Okay, so we might see something more here. So this criteria is basically to develop the dose response. The dose response needs to be developed to the general people, to the sensitive population. We want to save or safeguard our children, our infants, our elderly people also. So you have to look as to which is the sensitive population, and then derive from there your standards. So this knowledge of the dose effect or the cause effect or the causal relationship, if you like, that all depends on to the science or to the criteria that has been developed. So the people, lots of people work on this area, and there's a publication, and then when you are fixing your own standard, you should look for all the science that has been developed. Okay, so what I'll do is that this is a very important slide. I borrowed it from the net from someone. This was an episode happened in 1952, and that kind of, you know, caused a lot of this thing, and sometimes until lots of data that became available, people were using this as the dose response kind of thing, the criteria. 1952, the episode which was the London smoke, there's lots of things that one can talk about these things and how it happened, why it happened, and this is a picture from the BBC. And then you see here this side is the concentration of smoke and the sulfur dioxide in terms of milligram per meter cube, pretty high concentration actually. So what happened, because of some meteorological conditions, no wind and that kind of thing here, you see normally the level of this is the, you see here dashed line, this is the smoke. So smoke levels are normally like around 200. Can I say 200 microgram per meter cube? Okay, this is 1 milligram, that is 1000 micrograms, right? So something about 200 micrograms. So almost like the normal life is going on, you know, like, and somehow because of some reason the pollution started increasing, as you can see here, and this was the smoke, and you see the SO2 levels that was increasing. So they had some of the measurement, and some of the measurements were reconstructed. Okay, and this, of course, this is the fact as to suddenly when the number of deaths which were there, which you see on this side, about 250 or something per day, which are normal kind of thing, and it shoots, or it shooted rather, with as the pollution level goes. Death is a very serious thing. We want to even protect the people even from the ill effects in terms of the hospital admission, in terms of the feeling uncomfortable and that sort of thing, and having sore throat as you walk to the city and things like that. And death is very serious thing, you know, like, it's not a joke. I mean. And what you see here, that level going up, and then as the pollution started receding, things tend to become normal, but it takes a while before things will become normal. So this was one of the major incidents that people started talking about a lot of from the air pollution control, and some of the people used to even take this as the initial dose response point. You know, like, well, this the moment the level is slightly going up in terms of like 300, 400. Look, there could be rise in death or mortality even in the 1 day's exposure. I mean, we are not talking about the long-term exposure. Now the science has changed enormously. I mean, you know, like, so some of that science that is available to us now that we'll see now. This is the data we collected from the literature. What here you see here is the response. Okay, here response. Don't worry if you don't understand this FE1. Is the FE1 is something, let me explain you. FE1 is forced expiratory volume 1, that is in 1 second. Okay, this is one thing which shows about the healthy people. You should have certain amount of volume, you should be able to exhale it out with the huge intensity. So that is the amount. So if you are not able to do, means your lungs are not that strong. We'll discuss this later on when we talk about the health effects. So here we are talking the reduction. So here this is the ozone concentration. Look at these dots here. You see ozone concentration to 0.2, 0.3 or 0.5, and you see it begin to show in terms of the lung function parameter, because there was reduction and things like that. And the same thing, the people were just like sitting and all, but people, if they are doing some exercise, okay, see here, even at the lower levels, you know, like something like 0.2, okay, these effects can be seen. Okay, even this one. So below this, of course, the measurement was not there. So we don't know. So one may construct a graph like this. Okay, and we not only want to save the people at rest, but we also want to save the people during the exercise. In fact, the air pollution forecasting does tell to the people that, well, the pollution levels are going to be high. Not a very good idea for elderly people to go out and do the exercise. You know, well, because these are the effects. So. So I'm just giving an example. This is not the quite the way you do. Again, the standard can be. So that you see here, what is interesting here is that the exposure period is also very important. Just in 2 hours you can see the effects. Okay, so you propose a standard. You can do 1/10 of the 0.5. Okay, this is the for these people 1/10 of the 0.5. Okay, that is a factor of safety, 1/10 of 0.5. And this 2 was taken is because there is a difference between the ambient air and the exposure. Because exposure can be sometimes, these are based on the actual exposures, but the concentration sometimes is not equivalent to the exposure. Exposure can be less because you are all the time moving. You are not all the time in the polluted area, right? So sometimes you go to clean area, you go to city, you are polluted, you come back here. So that sort of thing. So here you see here, where are we here? So then it can be factor 2. This could be the background concentration that we cannot do anything. Okay, so this is what is in terms of the ppm, and then ppb it could be. So the standard can be 130 ppm. Just giving an idea, but these standards are not fixed the way we are talking. We have to generate the science, knowledge, and argument, but there are many levels of the discussion that goes on. So I want to just give you the feel, just not talk about the equations and things like that. You should understand what all goes behind making the decisions as well. Okay, so let's see, apart from this, there's another picture here. Here again we are staying with the ozone. Okay, FE1 decrement or the reduction. You see here, this is the volume per minute. Okay, so this is the normal volume which you and me will take. Okay, this is what it is. So what we found was that, well, when the people at the rest, okay, sitting comfortably, not so much effect is seen here, even with the higher concentration. Okay, but the people, if they are doing the exercise, when you do the exercise, what you do, you exhale, you inhale more air, volume is much more, and what you see with this picture here is that 40 liters per minute, you are doing the exercise, 31 liters per minute, and things like that. So here you see the effect is very pronounced. The percentage change of 16% is really, I mean, it is really causing problem to the person. Okay, and then you see here. So when we design the things, we not only design or the standard for these people, but also for these people. So you have to look for the sensitive population. So that is what is the thing. This is the source. This guy done a lot of work there. So you see the differences here. So again, it again tells you, well, that there is a fact depending on the what levels you have. In fact, we are slightly drifting, but that's okay. I was looking at one study, and the Chinese are trying to, because they're going to have the Olympics and things like that. So they are looking at the what will be the pollution levels, what could be the pollution level in whatever Beijing or whatever they are going to have the games. Well, can it affect the athlete's performance? Yes, a very important point. I mean, the person is working for 4 years, 10 years, all entire life to do very well in some international events. But if the place where he is, and because of the environmental problem, he is not able to perform to the level he is capable, I think we have kind of deprived him of his hard work, the results of his hard work. So these things also play a role, and so the implication of these things are very huge. So what you are saying, what I am trying to say again here is that you try to cover the people other than the normal people, and see here again, this was for the short term exposure, 15 minutes interval, the 2 hours. So just in 2 hours sometimes you can have the effect and things like that. Another picture again from the ozone. Okay, I'm just focusing on the ozone. So similar things are done for the other things also. Here you see again mean FE1 value. So here I'm not talking about the reduction, but I'm talking about the real value in terms of the volume you see in the liters. So not only that exposure was there, suppose you continue to expose person for the longer duration. Short term we have seen the changes. So suppose the person is exposed for the longer time. What happens? This person is exposed to the zero concentration. Okay, no change. It means he is performing, his lung function is normal. Okay. Okay. Look at this person. As he is being exposed for a longer period, his lung function is decreasing. Okay, The other curve was the reverse of this one, because here we are talking about earlier we were talking about the reduction, here we are talking the FE1. So, and look at this person, the concentration of the variable though here, that it decreased very sharply, okay, and then it tried to, set at some kind of equilibrium and things like that, and then maybe slightly improvement, because body also adjusts itself, you are constantly polluted environment, the body adjusts. So, why I am showing you this graph is, while there is effect for the shorter exposure, can you see that there is an effect with longer exposure also, right? I showed you the graph at 2 hours or 1 hour kind of thing. Here the impact is seen even the person exposed up to 6 hours. After 6 hours probably it stabilizes or something. So when it comes to making the standard, so what the time has to do with the standard? You tell me. There should be a standard for shorter duration and there has to be a standard for the longer duration, because the person can be affected when he is exposed constantly. So the averaging time for the standard can be shorter depending on the pollutant that we are talking about, or it should be standard. So the averaging time here, the averaging time will be little lower, the concentration will be lower as you have this thing. So many times for many of the pollutants we don't have the standard just for one averaging time, but we have for the many averaging times, okay. And see, why I am saying is, if I show you the ozone concentration and this is the time of day, okay, this is like, let's say 3 p.m. If you look at the profile of ozone, we'll learn that, but just for the time being, see, and this is the concentration. This may vary something like this, okay. If I give a standard of 24 hours, okay, the average of 24 hours will be almost like 0, because this is like peak for a certain period. But the point I am trying to make is, the person is, you give the standard for 24-hour average, 24-hour average will be actual concentration observed on the field will be very low. And they say, well, everything is fine, healthy, people are enjoying healthy life, but damage is done just for the short period of this peak concentration. As we have seen, that ozone can affect even at the shorter period of this thing. So it is erroneous, it is a mistake, it is an error on your part if you make a standard which is averaging time for this particular pollutant I am talking about for 24 hours. You have, if you don't have the knowledge, you have kind of made a terrible mistake, okay. So what I am trying to say here is, when you talk about the standard, we are trying to fix a standard. I told you that how the standard is fixed. Very important thing is the exposure time, or in normal terms we call the averaging time, okay. To specify the averaging time depending on the what pollutant that you are talking about. So there were more studies again staying with ozone. I just took ozone as an example, okay, and then you see here for the longer duration. So longer duration here there was no effect, but as the pollution level increases, so you can propose a standard even for 8 hours. So both the standards are important, 1 hour as well as the 8 hour. So same thing, 0.04 is the level where you are going to have some effect, is it right? 0.04, they say, well, this is the beginning point, take 1/10 exposure, there is different exposure into those background, and then you can say, well, the 8 hour standard should be 110. So which standard will be lower, 8 hour standard or the 1 hour standard? 8 hour standard is lower, because the exposure time is more, so averaging time is more. So the level here is, suppose I have to fix 8 hour, then something 8 hour average, 8 hour factor, 8 hour concentration can be fixed at here, but for 1 hour I probably will fix a standard, okay. So this is important to understand how we deal with the problem. Very good. Let's go further. If there are no questions, let's go further. Now same thing I am talking about the particulate matters, okay. Here what you see here is a particulate matter is a PM10. We'll define the PM10 at some stage, but what you can understand from PM10 is the particles of size less than 10 micron. Let's write that so that we'll discuss this a great deal in this course, PM10 business. particulate matter or particulate with diameter. This diameter is a special diameter that we'll define later, less than or equal to 10 micrometer, or okay, all right. Just to give a little feel that what kind of tiny particles we are talking about. The particles are even smaller than this. How, just to give a little feel, the diameter of the hair, okay, one single hair of course, is about 50 micron. Okay, so we are really talking about very small particles. To give, just to give a physical feel as to how big or small 10 micron really is. Okay, so again there is some study. This is an Indian study, in fact, done by Chittaranjan National Cancer Research Institute. So they did, this is some parts of the Delhi. They had the measurement of the particulate matter, as you see here, the different ranges, and then you see mean AM. AM is a measure of a body response called alveolar macrophases. Okay, if you don't remember it, that's fine. Okay, the alveolar macrophases, what happens is the body response the moment the body is attacked by the external thing. So body thinks this is a bacteria that has come, so it kind of produces some kind of, the another body which engulfs these bacteria and kind of kill them there. Okay, so if you have more pollutant particles, that body doesn't know whether it's bacteria or particles, so it just produces more of macrophages, and then it tries to engulf those things. Okay, they engulf, and then they think that, well, body can destroy that one. So you see here in the area where the pollution levels are high, so body response in terms of the number of the macrophages. This is the per HPF is more in the magnifying terms. You see here when the pollution level is high, it should be high. Okay, when the pollution level is low, the macrophages, your body is happily sitting, it doesn't need to do anything. But the moment the pollution level, body is responding. Okay, and then this kind of plot can be made, and you see that what levels you want to fix to the people, so that so something close to 100 or something that we can fix, because after that the kind of background level. So you see, with this knowledge that we should use and try to fix a standard. And okay, so again we are defining the criteria. Okay, criteria is a complete knowledge about dose response relationship for the pollutants. It is just not only what happens at the various doses, depending on the time concentration, depending on the averaging time, depending on the exposure time, and it also accounts for the people who might be at the larger distress. It can be the children, the infant, the elderly people, the adult people. So this is the complete knowledge. Okay, and that's what we use to develop the science, the standards, and the standards are legally binding concentration in the country right from the criteria. So that is the basis, that is the knowledge, that is the science, and standard is a more subjective thing which we all sit down and try to figure it out what should be the standard. Factor of safety and the other consideration, the following point should be considered at the time of the deciding the standards. This is very important. Averaging time. I have kind of given you a little feel that how the averaging time is important. Okay. Then we cannot say that, well, that is a deadline, it should never exceed, otherwise, see, sometimes things are beyond your control. So some accidents you should allow. Okay. So like for example, it could be 98 percentile, it could be 95 percentile, and things like that. So, and it should be specified, it should be mentioned. Okay. And then you should also specify the method as to how you will do, because different methods can have the different precision and accuracy, so they might give the different. You also specify, because we are talking a law here, and law is not like kind of fuzzy, something very clear and lucid. So here you say, well, the methods needs to be specified along with the accuracy and precision. Local air quality levels we should consider as to what are the local or background levels, as we have done in the past. Economics of the local area, that can also be very, very important. So sometimes standard, you may have the national standard, but local area standards can again change. It's not it's standards. We are only making it, well, we want the people to be, and it's a trade-off. You say, well, I don't care whether the industry is there or not. I want a better environment, the cleaner environment, and if the society agrees on that, well, who stops you? So these are the considerations that should go in. Okay, this is something which we'll discuss later on. But you see here, many of the pollutants are changed through the chemical transformation. They become, while they are emitting, they are something else, and while they come out in the atmosphere, undergo some chemical reaction transformation, and they change. Okay, if they are changing, so that changed thing can be another pollutant, and the standard for that pollutant will decide as to what are the standard for the other pollutants. Okay, from the parent compounds. We'll see that later on, and then we have the guidelines, that is the desirable levels, or we don't want to put the legalistic terms, so this is our goals, like that sort of thing. Okay, so in this process what people have done is, for the better management of the air pollution, certain pollutants are called as a criteria pollutants. Criteria pollutants are those pollutants for which they are very common pollutants found in the atmosphere, and for which the criteria have been developed fully. More or less we know as to what happens and how it happens and things like that. And also these criteria pollutants generally show a threshold. Most of the criteria pollutants, as you see, dose, response, they'll show some kind of threshold before picking up. And many of the compounds, many of the pollution thing do not even show any dose. Okay, so when you look into any air pollution book, suddenly you'll find the criteria pollutants and the non-criteria pollutants and things like that. So these are the pollutants for which the criteria are available and fully developed and understood. Omnipresent, therefore they pose the greatest overall threat to the human health. So because you see, for example, suppose I want to fix something for some standard, let's say for some compound which is likely to be never in the atmosphere. What is use of putting so much efforts and energy? But particulate matter, you will always find dust in the atmosphere. Sulfur dioxide will always be there. So will be NOx. NOx is defined as NOx, and I should define this NOx now. NOx is a general terminology. It's simply a linear sum of NO plus NO2. Okay. Okay. So that's what we call this as NOx, and carbon monoxide, lead, and ozone. Okay. And non-criteria pollutant, there are many in this list, because the rest all will be non-criteria pollutant. There could be asbestos, there could be vinyl chloride, mercury, arsenic, TOC, there is a trace organic. Read this as a trace organic compound, okay, not like carbon, and others that, of course, for which we can fix the guidelines, we can have the program to reduce them, but these are the things which are so much there, they need very special standards and things like that. There are another category called HAPs, okay, about the air pollutants, and they're called hazardous air pollutants. Their sources may be limited in this certain area. You go to a refinery, then you can find a lot of organic compounds. Okay, they are more toxic and carcinogenic. Okay, okay. There are such about 188 chemicals have been identified. To give a little example, the benzene, formaldehyde, cadmium, and there are all kinds of things that goes on. HAPs are more toxic than the criteria pollutants because they may reasonably be expected to result in serious irreversible damages, including cancers. So, for example, you have the chromium, mercury, the benzene, and the VOCs. There's again volatile organic compounds and things like that. So, for these we may not have the standard, we may have the goals, we may have the guidelines, or we may simply have the plans to reduce their emissions. Okay? But now this topic is becoming very, very hot because the criteria pollutant people understand, and if not in our country but in most of the countries, the criteria pollutants have been controlled well below that concentration that we are trying to arrive at. So a lot of efforts are now onto reduction and understanding the HAPs because we are all somehow dealing with this one. So I'll give you a little feel, okay, that how various countries can react to the problem differently. Okay, here this is for, we are talking about what, NOx we are talking about, NO2 for that matter. Okay, you see here Israel also, all right, we will accept, we want to develop or whatever, like the Poland, Saudi Arabia, Argentina, where WHO, you cannot call it WHO standard, but it's a recommendatory value or recommendation that becomes a. But sometimes you see the many countries may have the standard, but they may not very aggressively implement those. But then what I am trying to say is very, very much a state subject as to what levels you want to fix and things like that. And then you see what is important is always specify the averaging time. Otherwise it has standard without averaging time has no value. This for PM10, you see here the WHO in 1987 recommended this. I don't know why these people have very high standard, and Indian standard, we have the Indian standard for PM10 24 hour is Indian standard is 100. So we are somewhere here. Somewhere here is Indian standard. But these things are under revision right now. It probably will change. And we should, all the countries, they keep revising these numbers. Because more and more knowledge, more and more science is available. So you try to improve upon the standards. Okay, this is what is the national standard in India as of now. Okay, that may change. I will give you 1 minute at least to see, and are these standards fulfilling at least the description part. Okay, forget about how the numbers have been arrived, but the way these standards, because it's legal things. Okay, so here in India what we have is we have the 3 areas, there are 3 standards for 3 areas, very sensitive area and the industrial area and the residential area. So sensitive area can be very special, national park or ecological park, or there's something very special which you want to protect. For example, Taj Mahal you want to protect, so that can become a sensitive area. Okay. You have in the Western Ghats and Eastern Ghats, you have very fragile ecology we have, so that can be a sensitive area. But that is the government declares or notifies that area. So just you see that you have a pollutant here, the averaging time. So important to specify the averaging time, and then put the levels. Where are the units? Haven't they mentioned units here? That is mentioned, right? Okay. Oh, okay, that's mentioned. Concentrated microgram per meter cube, unless mentioned otherwise. Okay. So you have standard for suspended particulate matter. You have finer particles. You have the lead, and then you see when it comes to the annual standard, the levels are lower. Okay, or yes, and then you have for the carbon monoxide. Carbon monoxide concentrations are, I mean, this is still very, very stringent, I would say. Very, very stringent standard. You have the ammonia, which is again 400 microgram per meter cube. This is somewhat higher. And then it will go and specify what sample will constitute as an annual sample. So you can't say I've taken the 20 measurements, sir, this is my annual standard, it is exceeding that. No. We are talking law, we are talking legal terms, annual arithmetic mean of minimum 104 measurements in a year, not that you have all the measurements you have taken in January, February, March, but in a year taken twice a week, okay, 24 hourly at a uniform interval. You can do more than this, there's no problem, but then we have to be very, very clear, the 24 hourly, 8 hourly value should be met 98% of the time, okay. However, 2% it may exceed, but again there is a rider on that, exceed, but not on the 2 consecutive days. Okay, so that people can demand that compliance with these numbers, and the industry, when they do the planning, they will restrict their emissions so that these levels are still attained. So there's lots of meaning into these numbers, and therefore a lot of energy goes into fixing these numbers. It's just simply not an ordinary thing. You sit down across the table, let me write some numbers. Okay, that doesn't happen in that. Okay, maybe this is the last slide. Okay, summary of everything. Okay, before we get into the more technical stuff, the slide, I must acknowledge her. Let's see the system. There are the emissions. Okay, and then the emissions. Okay, you can have many emissions. So when you are trying to manage air quality, so you have to understand. Suppose I'm doing on GIS, so there can be a map overlay of the emissions. What will happen to the emissions? That it will be transported. Okay, so I must have the meteorological measurements. Here you see the meteorological measurement, the wind speed, wind direction kind of thing, and the rainfall and this and that. And then you kind of do the interconnectivity in between these things to be able to say what will be the exposure. Okay, this exposure to the people, to the plant, to the children. Okay, exposure not only in terms of you can do some measurements, as well as you can model, because you know the science so well, so you can model and then look at what is happening in terms of the dose response the way I did it. Okay, well, there might be some effect or there might not be some effect. Then you do like what economist does, do some kind of cost benefit analysis. Well, if I reduce from here to here, what I'll gain in terms of the health improvements and how much money that I need to spend. Okay, so you do some kind of cost benefit analysis and things like that, and come up with the best clean air options or strategies or plan, whatever you like to call, and then you go to the industry or to the polluter. Well, come on, this is what we have come up with. You bring down your emissions, this, that. Or even you can tell to the people, I'll change your habits. Okay, this is what you need to do, or this is what you need to do. Well, looks very good hypothetically, but when we implement this one on the field, there are lots of challenges, and especially in the country like ours, where the lots of poor people are there, and some decisions can affect poor people more than the rich people, and sometimes we have to take care of that. We have to have our we have to keep that thing in the bearing that, well, like in the process you might make them suffer or they lose their livelihood and things like that. So lots of things, but this is what is the general approach. And now in the next class we will be a little bit talking more engineering and things like that. We'll stop here. Good. Thank you.